This is Physics 102A, Chapter 7 Solutions at Porterville College. This is numbers 40 and 41. And in my main solutions video, I showed how to do 40 and 41. On this video, I'm going to show it using the graphing calculator. So the first thing we can do is enter the formula, which is 5 times the cosine of what do we say, parentheses, 0.25 pi times t. For the calculator, we just say x. There it is. Now, one thing we need to remember to do is to put our calculator in radians mode, not degrees. Go back to graph. Okay, so there's the formula that we're going to use. Now, we need appropriate windows. The problem in number 40 says to do this through 2 oscillations. We decided in number 40 that the period is 8 seconds, so 2 oscillations will be 16 seconds. So for that, you go to Window, and x, which is time, should go from 0 to 16. The scale 1, doesn't really matter what that is, but that will be a tick mark for every 1 second. Y minimum and Y maximum. We know it's going to go down to -5 and up to +5, so let's keep that there. And we hit graph. And there it is, just like we showed it on the paper. There's 1 cycle at 8 seconds, 12 seconds, and 16 seconds. Now, question 41 asks, what is the position at various times? Once we have it in the graphing calculator, this is kind of neat. You hit the trace button, and then this here says x equals, and we can enter in any amount for x, which is time. So 0.25 seconds. And there it is. It shows the cursor right there at 0.25 seconds. And down here, it says at x equals 0.25 seconds, y equals 4.90. Now type in another x value, 0.5, enter. And then it says y equals 4.6. At 1 second, enter. There it is, and y equals 3.54 meters. And we can check just to make sure, because if this is accurate, then at 2 seconds, that's a quarter of the period, it should be right at 0. So I hit 2, enter, and there it is. So a neat way of using the graphing calculator to solve these problems.